All right, let's give this a shot. I had some positive feedback on the video. Seems like they're about half of you like these videos, and the other half of you don't hate them. They're okay. I'll take the compliment. Maybe you prefer the live Mr. Salt to the videoed Mr. Salt, but I'm still coughing quite a bit. I will try to press the pause button this time if I cough, and hopefully this will save my voice for tomorrow. And I am feeling better, so I don't know how much longer I'm going to do these. These are a little bit of extra work for me to put these videos together. Also, I like the fact that these could help students that aren't here, that are absent, that want to do this later. So here we go. For geometry for February 12th, right? Unit 1, Lesson 10, the learning target that we want to keep in our mind out is that you want to be able to say, I can match worded descriptions of transformations to visual representations of transformations. I want you to be able to match worded descriptions of a transformation to visual representations of the transformation. All right? That's what I want from you today to be able to do, and that's what we're going to work towards. So on the warm-up here, we've got these 4 things. Now I'm going to do this one here and this one here. So I'm going to do the top left and the bottom right, and I want you to do the top right and the bottom left. All right, you're going to do those 2 after I show you how to do these top. Let them remove that camera just a little bit, just like that. That way, okay. So first one here, the description is rotate 100. These descriptions and representations are actually already kind of done. It's just the middle step is missing. So we're filling in the middle step. It says rotate 180 degrees about 0.02. So this one only has 1 step, actually. There is no missing middle step. But this is funky. It's a rotation. We haven't done this yet. We're rotating. Well, what's a rotation? Well, what do you think about? When you think about rotation, what do you think of? Let's stop the video and people call out what they have for rotation. And we're gonna unpause the video now. All right, we've got some good ideas about what rotation is. All right, yeah, wheels rotate. If you can see my little compass wheel here, this is rotating. It's going around and around, right? A rotation is when something goes around and around. So we're going to rotate 180 degrees. Where have we seen this before? Maybe we want to pause the video here, or maybe we just want to shout it out. 100 degrees, we saw that when I talked about how many degrees in a straight line, right? I said, hey, if in a circle there are 360 degrees, if in a circle there are 360 degrees all the way around, 360, in a straight line across that circle, it's going to be half of 360. It's going to be 180. So we're going to rotate this triangle 180 degrees around 0.02. Remember, 0 is my x value. The 2 is my y value. This is coordinate notation. All right. So where is this point, 0,2? It's where x is 0, so where I'm not left or right of here, I'm right there. My y value is going to be 2, so I go up to 1, 2. This point right here, I'm going to rotate this triangle 180 degrees till I get to this triangle. No, I take it back. I'm going to rotate this one to this one. Notice that this one has A, B, and C. That's my original. This has A prime, B prime, and C prime. This is my triangle after a transformation. All right? So I'm going to rotate 180 degrees. So what would it mean to rotate this C 180 degrees? It would mean half a circle. Now I wonder if I can make this compass work to where I really want it to work. I'm going to have to leave my seat to make this happen here. I need to find C. That's a good approximation of C. Whoops, I moved my compass. Such a small circle isn't always the easiest one to do. I'm having trouble with my compass. There we go. Come on, compass, spin. Spin. Oh, this is just embarrassing at this point. All right, well, I'm not getting there. We go. I had to help it. All right. Can we see the 360 degrees of the circle? Notice that this is going to be half of a circle in rotation. We're going to rotate 180 degrees. We get to here. That's 180 degrees, half a circle of rotation. We're going to keep doing that for all of these. So A is going to rotate in a big circle all the way around until it gets there. Let me see if I can use. Is it possible for me to use this compass and do such a big circle all the way around? Let's see if I can do it. Again, I never trained on these safety compasses. These are new to me. They're unfamiliar. All right, let me try it. I'm going to try to get my circle. I'm going to have to move my paper. Pick the same one. All right. Well, must not got the circle right on the center there perfectly, because I went through my line here, but didn't go quite through my line here. But in a perfect circle, if this was the center, rotating 180 degrees, my blue line should have gone through this A prime, and this would be 180 degrees, a half circle turn from A, half circle turn to where A prime is. And B, it's going to be the same idea. It's going to be a line that goes straight through the center. Oop, straight to the center, a straight line. Sorry that I goofed that up there. B is going to turn 180 degrees around that center until it does a 180. It does half a circle of a rotation. And then after each point on my triangle has done a 180 degree rotation, that's how these lines are kind of crisscrossing there, right? I have A prime, B prime, and C prime, and notice how the rotation makes the triangle flip upside down, right? By translating this thing 180 degrees, the triangle is now upside down from the position it was from grid 1 to quadrant 2. We'll learn more about quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That's what we call these quadrants. All right? Now, that's rotation of 180 degrees. So hopefully now you'll be able to figure this rotation right here. When you do this one here, you'll be able to rotate 180 degrees around the origin, which will require you to do this procedure here. You won't need the compass. If you can envision it, you can eyeball it if you want. I'm curious to see how you do this, how well you do. All right, so now we're going to do this one. I'm going to do this one because this one has a good example of rotation. This one has an example of translation and reflection, which will allow you to be able to reflect over here, rotate here, and reflect here. So we need to really pay attention to the reflection here, because most of what you're going to do on these two are going to be reflections. Again, these are all transformations, rigid motions they're called. So my instructions here are to translate down 4 units. I'm going to translate down 4 units and then reflect on the y-axis. So let me do this. Translate each coordinate point down 4 units. That's not too bad. So B starts here. I need to translate down 4 units. 1, 2, 3, 4. This I'm going to call B prime prime. All right. Translate C down 4 units. 1, 2, 3, 4. C prime prime. Translate A 4 units down. 1, 2, 3, 4. This is A prime prime. All right. You see my triangle? I've translated it down 4 units. The triangle's still there. It hasn't changed orientation. It hasn't changed shape. It's the same triangle translated 4 units down. And now it's going to say, and then reflect about the y-axis. So then we're going to reflect on the y-axis. Where is the y-axis? Pause the video for someone to shout this out. Come on, we know this. All right, unpausing the video. Well, this is the y-axis, the up and down. There's the x-axis, side to side. All right. So we're going to reflect along the y-axis. What does it mean to reflect? Where do you use that word usually? Like in a mirror. Uh-oh. We might have a visitor. Hello, who is this? Hello, Freya. How are you?
Good.
Did you just get out of the bath?
Yeah.
You wanted to make a quick appearance to my geometry class? So, Freya just got out of the bath. She loves the camera. So, here we go. Hey, say hello to my geometry class, Freya.
Hello.
How was the bath? Did that work out good for you?
Yeah.
Okay. You have anything to say to my geometry class?
Yeah, but I gotta show you my rudest goat noise ever.
The rudest goat noise ever. Okay, show it to us. Come on. Okay, loud. All right, go. Leave me alone. Give me some time, all right? All right, that's the rudest goat noise ever. You guys asked for my kids. There they are. One of them at least. Half of them. All right, I was going to pause. Hold on, I got to pause. Okay, soft. All right, here we go. Where was I? Oh, yes, I'm reflecting along a y-axis over here, right? So there's the y-axis. I'm reflecting. So when I'm reflecting, it's like a mirror, right? This y-axis could be the mirror. I'm going to reflect exactly the same number of units on either side. So this A goes 1 unit to the mirror. That means I need to go 1 more unit to the right to get to A prime. C is 1 unit away from the mirror, so I go 1 more unit away from the mirror to get to C prime, and there it already is. And B prime is 1, 2, 3 units from my mirror, so I go 1, 2, 3 units to B prime. So that's how reflection works. You figure out where is the mirror located. Sometimes it's located where, like this one here, is located where y equals 2. Y equals 2 is a mirror line that goes to where all the values where y equals 2. You got to go now. You want to show? Okay, she wants to show you her Vulpix. This is her new Pokemon, Vulpix. Hey, okay, now you got to go. I got geometry to teach. Go. All right. Sorry, no, my mind's somewhere else. I'm going to pause because I got to cough. I'm getting better at the pausing of the coughing this time. All right, now it's up to you. I want you to try these other 2 warm-ups while I take attendance. Well, maybe I've already been taking attendance since this video's been playing, but now it's on you. Try these next 2, all right? Let's take a minute, pause the video here, and we'll see how you do. All right, well, let's see how we've done. Reflect, this one here says reflect on the y-axis, and then reflect about the line y equals 2. So reflect, I have to first reflect on the y-axis. Hopefully we know by now the y-axis is right here. We're reflecting A across the y-axis. 1, 2, 3, 4, 5. Now I have to go 1, 2, 3, 4, 5. So actually my A prime prime is going to end up right where my B is. My B prime is there. All right, we'll see how that works out later. It's going to be there. Can you see that? Yes. Okay. Well, I'm going to cough. Got to press the button. All right, I got to close this door. Okay, sorry about that. I'll cut that out, and I wish there was a way to flag video. Okay, I'm just going to keep going. Reflect about the line. Y. Okay, so I've only done 1 over here. I did A over there. I now need to reflect C. C is 1 unit away from my mirror. I have to put it 1 unit away from my mirror. C prime prime. All right, and then my B is going to be reflected over my mirror. 1, 2, 3, 4, 5 units. So 1, 2, 3, 4, 5 units here. So my B prime prime end up the same place my A prime will be in a minute. And I already highlighted this y equals 2 line. And my next step is then to reflect about the line y equals 2. So here I go. My new mirror is right here, this line. Here's C. I'm going to reflect over the mirror. I'm 1 unit away from the mirror. I'm going to reflect it on the other side of the mirror, 1 unit. There's my, well, actually, sorry, this is my C prime prime. I'm going to reflect that over my new mirror, 1 unit. So there's my C prime. There it already is. My A prime prime is going to be reflected over the mirror, 1 unit. So I go over here. There's my A prime, already mapped out. B prime prime, reflected over my new mirror, becomes B prime over here. So then here's my new triangle. My old triangle. My prime prime triangle is translated right here. After the reflection, where y equals 2, I have this finished shaded one right there. How'd you do? Pretty good, hopefully. I mean, this is brand new. If you did good on this, feel wonderful. wonderful because you tried something new and you succeeded. And if you didn't do so well, don't feel disheartened because it's new. We'll get better at it. This is the first. I'm just kind of throwing you in the water. This is what a lot of this unit is. Kind of previewing all the kind of cool stuff we'll be doing, and then we'll get into some more nitty-gritty stuff as this unit continues. But I wanted to introduce you to these things now so you at least have some fundamental skills and some background as we proceed forward. And, we've done Algebra 1 for so long, I figured it's time to just jump in to geometry and go nuts. So, rotate 180 degrees about the origin. So where is the origin? Pause the video. Please, someone shout out. Please tell me someone knows what the origin is. Please. Okay, unpausing the video. The origin is 0, 0. It's right there. That's the origin, okay? And if you didn't know that, that's okay. Just make sure you remember that one. All right. And we're going to rotate 180 degrees around the origin. And we're going to reflect around y equals -2. All right, so we're rotating first. My first step is to rotate A 180 degrees around the origin. Well, I don't always do the circle method. If you did the circle method, that's fine on this one. But I like to think of it like the box. I'm going to take this box that's along here, and I'm going to rotate this 180 degrees. If you can kind of envision this, I don't know where this came from. Here's a box. I just grabbed a piece of paper randomly from this table. And if I'm turning it 180 degrees, it's going to turn like this over here, right? So this box I have here is going to flip until I have A prime is going to be right here, where T prime is. Oh, I got to pause. I'm going to cough. All right, back. All right. And where was I? Okay, B. I'm going to rotate B again. I'm going to think of this like a little box I have to rotate. That's the way I envision this better. If you want to do the circle, if you want to do a compass, measure around and measure this out. But for me, once I get the box, I can kind of envision how this goes. This box is going to turn 180 degrees. This box is going to be here. I've got to figure out where B goes. B is going to be this dot right there. B is going to be that dot on the new box, just like A is transformed into a box that goes here. The A box got turned 180 degrees. The B box is going to get turned 180 degrees. Now I've got B prime right there. And C is its own little box. Rotated 180 degrees. This box is going to become here. And it's going to be this point right there. That's going to be my C prime. All right, so I can already begin to connect this up. I can connect these prime dots, and I get my first rigid motion, my first transformation, a rotation of 180 degrees. I've translated this triangle, or transformed this triangle, rotation 180 degrees about the origin. And there it is. And it says then reflect around y equals -2. Y equals -2. That's this line. Hopefully you got that. Showed you what it was up the upper right hand corner. Hopefully you got this one. Now to reflection on this line here. So now I'm going to reflect my C prime. C prime becomes C prime as it reflects 1 unit past my mirror, my reflection. My A prime gets reflected 1 unit over to where A prime is over here. My B prime is only 1 unit away from my mirror. So that gets reflected. So give me this smiley face response, reflection to this. Tell me how this was. How did this warm up feel to you? Am I throwing you in the water too deep, or is this fun, or is it scary, or because I am. I mean, usually geometry, and I will slow down to do this, but I'm throwing you kind of in to give you kind of a taste. But usually I would do one thing at a time. I would show you rotations. We'll just spend a whole day on rotations. And then we'd spend a whole day on reflections. And then we'd spend a whole day on translations. Actually, do the translations first, and then the reflections, and then the rotations, in that order. And then we'd throw them all together into a lesson, right? But I like to take a big view of things and then zoom in. Because sometimes if we're always zooming in, then we don't see how everything's connected. We don't see where we're going with this, and then people get frustrated. So my thought was like, I'll give them a taste of where we're going. It's not too hard. I don't think this is too hard once you get an idea. We'll focus a little bit more as we go forward. We'll really refine those skills and everything will be great, and it will have seen the forest and the individual trees, and our perception will be good. All right. So changing this page here. So let's see. I got a rotation of 180 degrees around 0.02. We don't have any helps this time. We got to do it all ourselves. And then this one here is going to be a reflector on the y-axis. So here we have a rotation. You know what? I'm going to give you some time. Let's pause the video here. Let's see if we can do this. Can we rotate 180 degrees about 0.02? Let's take about a minute. Pause the video here. Let's see what we can do. Okay, unpausing then. Hopefully we're doing okay with this. So first we need to identify where this point is. 0, 2. This is the x value, comma, my y value, where x is 0. Where is x 0? It's 0 there. On this line, this is where x is 0. This is known as the y-axis, where x is 0. Then my y value is 2. My y value is 2 right here. So on this point, where x is 0, y is 2, that is my point. I'm going to rotate this all around. Now C is going to be my easiest point to start rotating, because 180 degrees, that shows up right there. That should be, I don't even need to draw a box to visualize what 180 degree rotation is for C right there. B, I'm going to try to envision the box. If I envision the box is going to go here. The box is going to get rotated 180 degrees, and B is going to be on this part of the box. Now I can just visually see that. Maybe you, again, want to use your compass. Maybe you want to use the compass and get a good feel for where that is. Oh, it helps when your compass is right side up. So B, again, my circle isn't perfect. I don't know why I keep getting off on that. But as you can see, here's my 180 degrees of rotation of B going here. You can do it either way. You can either use your compass, or you can visualize the box method. Either way works, and either way is good. Whichever gets you the right answer, that's what's important. So now what? Now what? Okay. You gotta rotate A. So if you can you see that box? So that the box would be too high. It would be 1, 2, 3, 4 units. So this is the box I'm envisioning that I'm about to rotate. Rectangle there. And rotating that 180 degrees means it's going to show up 1, 2, 3, 4. So 1, 2, 3, 4 over here. So this is my new box as it gets rotated. For some reason, it's really easy for me to see rectangles get rotated along a corner, and it's really easy for me to place. Okay, A is here, my A prime. This is my C prime. This is my B prime. All right. It's really easy for me, for some reason, to be able to envision those boxes and rotate them in my head. If you need the compass, use the compass. It's okay. I'm just connecting the points of my triangle. Okay, we've rotated 180 degrees around 0.02. We're done. That's it. Give me that smiley face reflection about how this was for you. Smiley face for that's easy, Mr. So. I like this. Frowny face for, oh no, this is not comfortable. I don't understand what's going on. Something in between, like, oh, I kind of get it. Maybe I need some more practice. I'm not an expert at it yet. I'm not confident yet, but it's not scary. All right. Reflect about the y-axis. So step 1, reflect on the y-axis, and then step 2, reflect on line y2. Stop the video here. Have you get a crack at this? Take a minute. Take 2 minutes. Take what time you need. So at least most of the class is giving this a shot, and we'll see how successful we are. Okay, unpausing the video. A reflection on the y-axis. A reflection on the y-axis. We'll look. Here's the y-axis. Hopefully that's easy by now, right? So B, if that's my mirror, if this is my mirror here, B is reflected over 1 unit. There's B prime. C is reflecting 1 unit away from the mirror, so I'm reflecting 1 unit away from the mirror on the other side. Hold on, pause. Ooh, I almost was not able to pause that one in time. To spare you my coughs. So sorry. No fun being sick. All right. 1, 2, 3, 4. So my A is 1, 2, 3, 4 away from my y-axis. So 1, 2, 3, 4. There's A prime. I should have a B prime here. So there is my triangle after the transformation of a reflection. After my transformation of a reflection over the y-axis. I bumped into the camera. Never bump into the camera while you're filming. All right. Never spit into the mic. That's another rule of video production. Don't bump into the camera. Don't spit in the mic. All right. Then reflect about y equals 2. Where is y equals 2? Well, right there it is. Where y is 2 on my y-axis, I'm now going to reflect my reflection over this line. And let's see how that works. Well, C is in a funky position here. Do you see that? C is on the line. What do you think I do? Let's pause the video. What do we think we do about this? Huh? All right, I'm pausing. We don't do anything. We leave it right where it is. It doesn't need reflection. It's on the line of reflection. So, yay, for those of you who got it, and that's okay if you didn't. You're just taking a guess, right? Take risks. That's what it's all about. Take risks. You get all the answers wrong, you don't try. So we're trying to get you to a point where you can try everything, right? You can make a stab at it. Get some points on those part 2s and 3s. That's what we're about. All right? If we can get you to get points in the part 2s and 3s, I know you're going to do well in the multiple choice. That's a given. So here we go. There's the line. 1, 2 away from the line. There's B1. 1, 2 units away from the line. So I reflect over 1, 2 units. There's B prime prime. Okay, I'm going to press pause if we're coughing. Okay. All right. Thank you for bearing with me here. A is 2 units. A prime is 2 units from the line of reflection here. So I'm going to go 2 units over. So 1, 2 to the mirror. 1, 2 away from the mirror. There's A prime prime. And my C prime prime is right there. It's stayed where it is. So let's connect these dots and we're done. That's our triangle after 2 reflections. 1 reflection over the y-axis and 1 reflection over the line y equals 2. Boom. There it is. Oh, I got my pencil. Okay. Next page. How are we doing? We're about 27 minutes in. All right. Let's do this. Rotate 180 degrees about the origin and then reflect on the line y equals -2. That's our job. Rotate 180 degrees around the origin. Again, we know the origin is here. Shall we pause the video? You'll go for it from here. Pause it. See how you do. Okay, unpausing. I'm going to rotate this 180 degrees. Again, if you want to envision this box, the box is going to then be here. And the B is going to translate to there. Right there is where my B prime is going to be. Or you use your compass and you draw that circle around there. All right, there's C. Here's the box that I'm envisioning. I'm going to rotate 180 degrees. It's going to end up right here. And C is going to be at the end of the corner of that box. There's C prime. And now I'm envisioning this box of A. I'm going to envision it go down here. And A is going to be this point right there. There's A prime. Again, use your compass. If the whole box method doesn't work for you for visualization, that's okay. Use the compass. See how everything is always a straight line going right through. Real nice. That's another way to do this too. That wherever your A is going to, after a 180 degree reflection, if you draw a straight line from your original to the point of rotation, 180 degrees, your A prime, your 180 degree rotation should go through this straight line. Same thing here. If I'm rotating 180 degrees, then my B prime, this line from here to here, should extend out, and my B prime should be on that line. Same thing with C. Sorry, I'm going to make this kind of messy. with all these middle lines to show you how there's between here and here, my C prime is going to be on this line somewhere. It's going to be the exact same number of units that way. I'm going to have to use my blue pencil in order to show you the triangle that I've made, because I've made this diagram so messy in every other possible way. But you can barely see my blue pencil. There is my rotated triangle ABC, now A prime, B prime, C prime. And one more step to do, and reflect on the y equals -2. So y equals -2 is this line here. There it is. I'm reflecting. C's already on it. Remember, that just stays there. So my C prime prime stays right on that dot. A gets reflected 1, 2 units, so it's 1, 2 units away. There's A prime prime, and B is 1, 2 units away from my mirror, or my line of reflection. So it's 1, 2 units away. It ends up right back where C used to be, sorry. B prime prime, so my new and final triangle, after all is said and done, I've done all that work, it's going to be this guy right here. Maybe I wish I had a different color. With so many children, you'd think there'd be a crayon around here. That would be useful for highlighting the final triangle. There we are. Thank goodness for crayons, right? All right. Flipping the page over. I think that's our last one before the check for understanding. So if you're tired, yeah, we're on to the check for understanding next. And check for understanding is real easy. What did you learn today? Type of reflection. Okay, so one more. Don't give up on me yet. We're only 31 minutes in, 32 minutes in. All right, translate down 4 units and then reflect on the y-axis. This one's easy. Try this one. Take a minute. Pause the video. You can do it. Yeah. All right. Unpausing the video then. Translating down 4 units. Man, doesn't get much easier than translating down 4 units, right? Here's B. I'll translate down 4 units. 1, 2, 3, 4. There's B prime. Translation barely takes any thinking at all. 1, 2, 3, 4. There's A prime. And then C. 1, 2, 3, 4. Don't be afraid of translations. They're all right. Now, sometimes translations aren't just up and down. Sometimes they're like 4 down and 3 to the right. Don't worry. It's just then translation of 2 steps, you know. But don't worry about that. We'll get there. This is just showing, we're kind of previewing. We're trying to see what excitement awaits. We're going to hone and refine these skills as we progress. Making mistakes in math class is good, because then you learn from those mistakes and you don't make them anymore. All right? You don't learn if you don't make mistakes. Making mistakes and making errors is part of the learning process. You can't do without it. So I encourage you, always take the risks in math class. Make the mistakes. It's good. It's cool. All right. Then reflect on the y-axis. Or reflect on the y-axis. All right. Here's the y-axis. I'm bopping you over the head with y-axis, reflection over y-axis today. All right. So we remember where these are. Okay. Here's my mirror. Here's my A. 1, 2 units in my mirror. 1, 2 units. Look at that. A and B are going to switch places. There's A prime. I'm sorry. No, that's B prime. This is A prime prime. Anyone correct me on that? I hope so. There's B prime prime. And then C. C is 1, 2 units away. So here's my C prime prime. And I connect these dots. Now I've got my final triangle. Right? Any Dragon Ball Z fans? I've reached my final form. What do we have? A lot of Naruto fans here. What do we got? What's your favorite anime? Shout it out. What is it? All right. Of course it's Samurai X, or maybe Berserk, or Cowboy Bebop. You know. Okay, right. Anyway. That's our final triangle. Take the magic crayon over here. All right, great. Wonderful. Well done, everyone. Great stuff is happening today. We're 35 minutes in. Pick one of these reflection prompts. You've seen these before. Oh, I don't know. Let's see. One way you can to surface hidden structure is to Draw the boxes before rotation. You know, use little guides like that, or use the compass to do a 180-degree rotation to see that. You can use the find calculation shortcuts. Well, we really didn't do a lot of calculation today, so maybe skip B. Don't choose that one. C, the next time I will something before I calculate. Well, skip C. Property that comes in handy when developing a shortcut is, well, what shortcuts did we learn? Translation is just 2 units. It's just translating, it's just moving things around. Stays the same orientation. Rotation can turn things upside down and change orientation. It keeps the same shape. What other properties did we learn today? Reflections. Reflections keep the same shape. They can flip. They can change the orientation and kind of almost reverse, make the image backwards, right? Or E is an easy one to do. Paying attention to the directions. It's helpful because you want to get the answer right. I don't know. Pick one of those. Or just, say what you learned today. And we're going to use a compass and straight edge to do a square. Okay. Compass and straight edge to do a square. You remember how to do this? I know I just did this yesterday. But to me, it's kind of fun to play around with all these different shapes. Maybe you hate it. How about this? If you don't want to do a square with your compass because you did it yesterday, that's all right. Give me an equilateral triangle. Give me a isosceles triangle. Show me something cool. Show me anything cool on this space in terms of a construction where you're using circles to construct something. Maybe it's this hexagon. Maybe it's the 6 flower petal. Anything you learned in terms of constructions that you want to show. A perpendicular bisector would impress me right now. You want to do a perpendicular bisector? Look, we've actually done 2 perpendicular bisectors. Just by doing this diagram here, where 2 circles that overlap each other's centers happen, we get perpendicular bisectors. That's 90 degrees, that's 90 degrees. I'm going to cough, I need to press pause. All right. And hopefully remembered how to do our 4th and 5th circle. There's my 4th circle. There's my 5th circle. And then my square. Oh, I didn't do a 5th circle where I needed to, did I? I just went over the other one. There's my 5th circle. Now I have 5 circles. And there's the other corners of my square. La-di-da. I've got my square. That's the construction. Oh, did I do all that and then not show you? All right, well, hopefully that's not so bad since you can construct anything you want. If you're going to do a perpendicular bisector, let's do that. Here's a short line. I need to make sure that my circle is more than half the size of both sides of my line. Again, constructing something a little bit easier maybe. And my perpendicular bisector is right there, connecting where these 2 circles intercept each other. That's going to be exactly halfway in between, which means this piece here is equal to this piece here. These are the same. That could be x and that could be x. And then this also I know is 90 degrees. So that's what's handy about that perpendicular bisector. Hopefully someone showed an equilateral triangle, any kind of construction you want. That's cool. Go on this page. I'm happy. Let's talk about the reflection today. How do you still like these videos on day 2? Or are they a sour taste in your mouth? Give me the reflection. What's working? What's not working? Go for it. Pause the video here, and then tell me what's happening. Give me some feedback. Okay, unpausing the video. Homework. Like yesterday. I'll leave it up to you. If you want time to do these on your own, we did some of these yesterday. Say, pause the video here. And if you just like, no, my brain's shot, just show me how to do these. I'll just show you how to do at least 2 of these. And then we'll leave the 5th one or 3rd one there for you to do on your own. All right. Assuming you want to keep going. A is equal to C. So I'm sorry, AB is equal to AC. So here's AB. Here's AC. The little hash mark says that they're congruent. In fact, we should probably say they're congruent. And DCE, where's DCE? DCE, this angle here, is equal to 75 degrees. Again, these are Regents questions. BCD, is a straight, and ACE are straight lines. So it says that's a straight line, and that's a straight line. What is the measure of BAC? It says we want to find BAC. That's what we want. That's what we want. Now, you can solve this one on your own. You'll be very impressed because it takes some logical deduction and some theorems of triangles that we haven't quite dealt with yet. So, yeah. One of those theorems, that when two lines intersect, that the vertical angles will always be congruent. And the reason why is because every line is composed of 180 degrees, as we've already talked about, which means if I know the angle of 1, if this angle is going to be plus this angle will always equal 180, because all lines equal 180, all straight lines equal 180 altogether, which means if this is a straight line on the other side, then this angle has to be the same as that, because 180 minus this is going to equal that. 180 minus this is going to equal that, which means these two are also the same. So the vertical angles, the angles diagonally across from each other, are always congruent. So if I know this is 75, then I know this is 75. If you could figure that out just by knowing what we know so far about geometry, I'm impressed. And if you don't worry. This is stuff that boggled the minds of Greek geometricians who studied geometry for quite a long time. So they developed these theorems, and this stuff doesn't come easy. You have to really think about it and play with angles and really get an intuition and sense for it. But if that came easy, great. Okay, so the only thing we know is that these two sides are the same. Now, I want to cough. I want to pause. Okay. We know that an equilateral triangle, all three sides are the same. Then I told you that all three angles are the same. Well, this is not an equilateral triangle. This is what's called an isosceles triangle. Only two legs of the triangle are congruent. However, that gives me an interesting property. When two legs of a triangle are congruent, we will find that the opposite angles are also congruent. Just like the opposite angles on vertical angles end up being congruent. If this side and this side are congruent, then these two base angles are congruent, which means if this is 75 and these two sides are congruent, that means this is 75. This angle is also congruent. All right, follow me so far? Okay, good. And we know that all the internal angles of a triangle add up to, someone say it. What number do they all add up to? Always 180 degrees, 180 degrees, right? So now I can find this missing angle with just the information I have and knowing that they all will add up to 180 degrees. Unknown angle x, call it x, plus 75, plus 75. And again, this is where algebra and geometry meet, I'm afraid. We'll never forget our algebra completely. It'll always still stick with us. Here I go. I'm going to minus 75 and minus 75 to get x all by itself, which means I need to minus 75 and minus 75 over here. 180 minus 75 is 30. X is 30. Our angle is 30 degrees. Boom. All right, we're at 44 minutes. Class is by all the pausing we did, class is probably wrapping up. Let's see how fast we can get this one here. BCD straight line. ACE is a right angle. That's 90. Write that in there. That's 90. Oh, we have an equilateral triangle. That tells me all these angles are congruent. Boom, I know all that. Okay. Find ECD. I got to find this guy. Well, I know this whole thing's 180. I know this is 90. Okay, and then I got to, what did we tell ourselves? An equilateral triangle, the angle measure is always 60 degrees. Why is that? Because 180, if all the angles are the same, 180 divided by 3 is always going to be 60 degrees. So that's 60 That's 60. That's 60. Equilateral triangle, all the angles are 60. Gotta be. Gotta be. The whole thing is 180. So what's 180 minus 90 minus 60? 180 minus 90 minus 60. That's our missing angle. Boom. 30 degrees. 30 degrees. You do the last one. Have a great day. I'll be ringing any minute now.